And now we move to Viola and Manuel covering ethical issues. And I think that's really related to, MLOps, right? So please, Viola and Manuel, you can share your screen and get started.
I will start, Marco.
Okay.
Manuel will start and then I will continue.
Okay, excellent.
Okay. Can you see my screen?
Yes, perfect.
Okay. So good afternoon, everybody. Welcome to the talk about personalization. So to personalize or not to personalize, the soft personalization and the ethics of ML for health. I'm Manuel Roveri, but let me at first introduce you Viola Schiaffonati. Both me and Viola, we are professors at the Dipartimento Elettronica, Informazione and Bioingegneria of Politecnico di Milano. And as Viola was anticipating, this is a joint presentation. So at some point we'll switch the presenter because we are also physically into different countries today. But we are really very glad to present this talk, which is not just a joint presentation. It is the outcome of a collaboration aiming at joining, integrating in an effective, efficient way to different research groups, my research group and Viola's research group. So as I was anticipating, the outcome of our work, which is here described in this presentation, is the result of an really interdisciplinary effort aiming at joining two different research groups. My research field is the design and development of tiny mail systems. So I really enjoyed this workshop and what just described by the previous presenter. So we do as research the design and the development of tiny mail systems. So systems endowed with tiny mail algorithms. So algorithms designed to operate on tiny devices, technologically constraints on memory, computation, and energy. Viola's groups, so the expertise Viola is in ethics and in particular in the ethical concerns and value, with a particular attention to AI and health wearable devices. A big thank goes to the team members. It's for sure they are they really deserves a big thank because they are really looking after this very interesting research activity. So let me mention Massimo Pavanna, Alessandro Falcetta, and Stefano Canali. Okay, so let's start. Let me just go back on one slide, going back to the title, which relies on amuletic questions: personalize or not to personalize. Well, these titles highlights the three main perspectives that we want to provide in this presentation: the algorithms perspective, the technological perspective, and the application perspective. So from the algorithm perspective, we will work with AI, in particular with machine learning and deep learning. The algorithm perspective relies on AI. The technological perspective relies on IoT, so Internet of Things, wearable devices, while the application perspective relies on health. We will try to combine these three different perspectives within the umbrella of personalization, which is very close to the concept of adaptation configurations. And this is somehow related even to the last question, which had been asked to the previous presenter, to Colby, asking related to the effect of new data when they are used, when they're integrated to adapt or to improve the performance of machine learning models operating in real working conditions. So this is the title. In particular, we will explore the following points. So this is the outline of this talk, starting from the introduction, the large usage of IoT devices in the field of health. This goes under the umbrella of the health IoT. So we are seeing an expansion, really an explosion of IoT devices being applied to the health application scenario. In the field of medical and social care. But then if this is the technological scenario that we are seeing today, we have to ask ourselves which are the specific risks and which are the ethical issues that must be managed once we are considering health IoT. We will start from the related literature. We will highlight the fact that we see that we perceive that there is a lack of a systematic discussion, in particular when we are considering machine learning algorithms that are running on health IoT, so in HIoT. We will explore exactly the role of ML in IoT, and we will explore the impact on ethical concerns. We will then tailor this discussion into a specific use case, which is a real-world scenario related to the glucose monitoring of patients in order to raise alerts or alarms of critical situations. In particular, we will describe 4 different scenarios related to the technological scenarios and where the machine learning is running. So we have 4 different scenarios, and we will see for each of these scenarios which are the relevant aspects that must be managed. Once we designed these 4 configurations, we can then map the ethical concerns into these different scenarios. And at this point, we will be able to introduce the personalization. Personalization means that we are using more data in order to configure, to tailor a specific model to a given patient, to a given user. And we will see that this paves the way for new, better models, but it also opens some critical points that must be rated. Hence, in any case, adaptation represents for sure the new hope in 10ML. We will conclude with some comments and research directions, and this is the outline of this talk. Okay, so we started from the comments related to the 3 perspectives that we want to provide in this presentation. So we have algorithms, technologies, and applications. If we look at the technology and the application, so IoT and health, it is quite trivial to understand the importance of the role of IoT in health. We saw the blooming in the last, say, few years, but in the last even probably 10 years, the blooming of new devices, new personal devices aiming at providing health-related applications. If we look at our wrist, we will probably see a smartwatch monitoring the heart rate, monitoring the number of steps that you do every day. And we can see all the other scenarios of IoT devices that can support directly or indirectly the development of health-related applications. So we have the role of the technology. And before entering then into the role of the algorithm, I want to quickly make a step back and analyzing the strict relationship that exists between the algorithmic revolution and the technological evolution. We are nowadays talking about deep learning algorithms, which are, say, representing the state of the art in, say, most of, I would say, all of the prediction application, classification applications, or recognition applications. We are considering deep learning since the last probably 10 years, 15 years. But what it is interesting is the fact that the idea of deep learning dates back to the late 60s, to the end of the early 70s. So we had great ideas roughly 50 years before we were truly able to use these algorithms. Why we have this time gap? And this time gap is strictly associated with the technology. In particular, the technology we had at the end of the 60s and the early 70s were not enough computational powerful to train and as well as to make the inference of such deep learning models. So we had to wait up to the appearance of the hardware accelerator. So early year 2000s, so the GPU, the TPU, the FPGA, completely changed the perspective of the technologies and paved the way for the pervasive usage of deep learning algorithms. So we saw that there is a strict relationship between the technological evolution and the algorithmic revolution. So it is interesting today to see which is the next technological evolution that will support the next algorithmic revolution. For sure, since we are here, you trust us, or you agree with us that the next technological evolution is represented by the computing everywhere paradigm. So the ability to provide the computing units that operate pervasively in environment, acquiring data and processing data as close as possible to where data are generated. This is crucial for many different application scenarios, but it is particularly crucial for health-related applications. So IoT and health represent somehow 2 sides of the same coin. But then we have to explore the third perspective, which is the algorithmic perspective. We can now take into account the machine learning and deep learning. Here we are just presenting a paper which has been published some years ago on the magazine of the IEEE spectrum, mentioning the machine learning on the edge as one of the most interesting technological scenario of the future of machine deep learning. Here, in this paper, it is particularly highlighted the fact that the machine learning at the edge will drive better privacy practices, lower energy consumption, and build a novel application in the future generation of devices. So this is the scenario in which we are working from the algorithm perspective, but it is crucial to understand why we want to move the applications, move the processing, in particular the intelligent processing, as close as possible to where data are generated. We have several advantages in this ability to move the computation to IoT. At first, we can increase the autonomy of our units in the sense that if a device is able to take a decision, then it is truly intelligent, it is truly autonomous. So if we can process and make decision locally, then we have an object, a device, which is truly autonomous, truly intelligent. If we are able to take a decision locally, then we can for sure reduce the latency with which we make a decision. Because if we have to acquire data, move the data to the cloud, hence introducing an unpredictable delay associated to the fact that we are moving data towards internet, processing data on the cloud and waiting back for the results, again, introducing an additional unpredictable delay in waiting for the results, waiting for the feedback, for sure we will have a latency which is much higher than what we would have in processing data locally. Processing data locally allows also to reduce the transmission bandwidth because we have to transmit less data. Transmitting an information is much power hungry. So we require much more energy than processing data locally. So being able to process data locally allows to increase energy efficiency in our system. If we are not required to move our data outside the device, we can for sure increase the security and the privacy because we can avoid the leakage of information. If we can process the data and acquire data directly from the field, we can support the incremental adaptive learning, which is somehow related to the tiny MLOps just described. So if I'm able to exploit the data which are coming from the field, then I can improve the performance of my device. But then this also opens some issues that will be addressed in the second part of the presentation. And then we have to think about the fact that we don't have just one single unit, but we have multiple units. So we can scale our problem to an ecosystem of units. And then we have the drawbacks. The drawbacks are strictly associated to the technological constraints that we have in our units. In particular, we have very low computing abilities. Here you see in my slides, in our slide, an example of some devices which are significantly constrained in computation, memory, and energy. In addition, we have an increase in the complexity, which is associated to the fact that you have to write firmware and not just application relying on an operating system, and hence introducing the need of a strong relationship, a strong connection between, say, among hardware, software, and machine learning. So these three pillars, so the technology, the algorithm, and the application, bring us to the state of the art, one of the most promising and interesting scenario, which is associated to the wearable technologies. Here, the Economist is highlighting very well, which is the scenario we have, the quantified cells, with the idea of acquiring data, data which allows us to live longer, better, healthier. But here, the point is that we must wear technologies. These technologies are acquiring data, and these data must be processed in order to fulfill the requirements of a given application. So we have very, very big promises, like the ability to have personal medicine, so specific technologies which are tailored, not to a general patient, but specifically to me. This would allow us to better monitoring in the sense that if we have to identify, for example, anomalies, as previously mentioned, my anomaly could be different from someone else's anomaly. And this is related to the fact that I can support an assistance which is specifically tailored to me, to my behavior, to what I do, to my habits. So we have very big promises which are guaranteed, which are provided by the fact that we have technologies acquiring data, and these data are processed by machine and deep learning algorithm. But these promises come also with a dark side. And these dark sides are associated to the fact that we have some constraints, some issues, some concerns that must be managed. Here we will describe some of these concerns by showing some news appeared in newspapers. And this is a news that appeared in New York Times some years ago, which is related to a well-known activity tracker. And the news here is saying that this well-known activity tracker provides not very accurate, measurements during highly sporty situations, highly active situations, with respect to specific medical devices. So this is one interesting point, which forces us to say that hardware is not just a commodity. So if we provide the datafication perspective, so translating everything into data and then try to process the data, we cannot neglect how these data are acquired and how these data are, say, managed in order then to make a solid and a reliable decision. And this also opens additional concerns associated to the fact that these data are then processed maybe for surveillance, for profiling. So what do we do and what do they do? And then we will see what we mean for they with the data that we are acquiring. In addition to that, we have other concerns like, for example, this news that, sorry, it is in Italian, but I will translate. It's quite easy to be understood. Here, this title is, we have a smart toothbrush, which has been tested, this smart toothbrush. And here the comment is, there is AI, but it is not needed, which is particularly interesting, which allows us to point out one important point, which is the difference between a connected object and intelligent object. Often from the marketing perspective, they are exactly the same type of objects, but technically they are not. They are two different objects, because the connected object is an object which is able to acquire data and then send data elsewhere for the processing. An intelligent object is an object which is able to acquire data, process data locally, and make decisions. So here, this is exactly the dichotomy that we have to face. Are we just acquiring data and sending data elsewhere, or are we acquiring data to support local processing? This is an important point, which is also further related to the third point that I want to explore. Which is strictly related with the term of concept drift that has been mentioned in the previous presentation. Here, I'm mentioning here a news that appeared in IEEE Spectrum some years ago, saying this very interesting point. A research group from US made a very, very simple thing, which is the following. We know that here by here, we have a face recognition algorithm that are able to provide very, very accurate say recognition abilities. We go to 99.6, 99.7, and so on and so forth, but focusing on well-prepared, well-organized data set. This research group made a very, very simple thing. They moved these algorithms from the benchmark perspective to the real world. So they implemented and then they tested the accuracy in real working conditions. And what they discovered is the fact that the true accuracy that they measured in the real working condition was much, much less than expected. So going from 99 to 60, 99 to 50, 99 to 30. Why? Because in real working conditions, we might have a change in the statistical distribution of the data between the training and the testing. This has a strong impact and introducing a strong decrease in performance. But this is something that might happen very often, because if we have dust which is appearing on the camera, if we have different lighting conditions, I might have a mustache, I might have glasses or a hat. And this is something which is not foreseen in the training phase. But this is something which has a strong impact when we move a machine learning algorithm from, say, the benchmark perspective to the real world perspective. In addition to that, we have also other issues which are related to the fact that we have always to take into account the privacy and security standard. And often these security standards are not too high. As well as the user access and the ownership of data. If I have a medical device that is acquiring data from my behavior, from my habits, who is the owner of the data and why? And who is really able to look after the management and the ownership of the data? And then we already mentioned the term datafication, but this is something that we're already seeing. In particular, if we are considering private spaces, me, my house, my job place, as well as the scenario in which the medical services are becoming private. So who is then the owner and who is able then to process, who's in charge to process the data? Going up to the fact that if I'm generating data, who is able to reuse the medical data for other purposes? And are there limits of the informed consent? So is this something which is really an issue for a final user? We tried to put things on the ground by considering, as suggested, as anticipated, a real-world example. And this example is related to the glucose monitoring for diabetic patients in order to raise alerts or alarm when needed. So we considered the scenario in which we have a device that is able to acquire personal data and raise alarm or alert when needed. And this algorithm is able to process the data and the data which are acquired and then processed by means of say machine or deep learning model. Here we have two main points which must be raised because we have to take into account the technological perspective here. So which are the technological actors which are involved in the processing? Technically, which are the level of processing that can be considered? And second, how can we get a personalized models for the glucose monitoring? Can I scale up my general model to a personal model which is able to tailor into account my specific behavior, my specific habits? In order to answer the first questions, we are considering a quite general scenario in which we have a three-layer perspective. We have the final user, so the patients, we have the device, and we have the cloud. This is a quite general approach, which could be further considered more complex by introducing, for example, an intermediate edge computing layer. But let's keep it simple. We have device and cloud. We have then to consider where we are running our AI model. And here we have the scenario in which scenario number one, which is the easiest scenario, which is the most traditional one, in which we have the inference on the cloud on a predefined model. What do I mean? We have a large number of patients representing a training set. A general model for glucose monitoring has been trained by, I don't know, a private or a public company. This model is running on the cloud, and the device is able to acquire data from the patient, sending the data to the cloud for the processing. On the cloud, we have the general AI model, which processes the data and then raising alerts, alarm if needed, and then these alert alarm are propagated to the device and then back to the final user. This is scenario number one. The scenario number two, we still have the processing on the cloud, but we can take into account the fact that at the beginning, for example, at the early stages of the usage of the device, we can acquire some data from the final user, and we can create a personal model. So we have personal data which are still flowing from the patient, from the person to the cloud through to the device. But then these data are used to fine-tune, to personalize the model, but then the model is still running on the cloud. So we have to send to the cloud both the data for the training and the data for the inference. And then we can think about moving the computation exactly following the 10ML perspective to the device. So in the scenario number three, we have the inference on the device, hence following the 10ML approach, but on a predefined model. So we still have the model trained on large sets of patients, but then this model is executed on the device. So here we don't have connection to the cloud, or we might have connection only just to say the system is working or providing some specific highlights or KPIs. But here, the main point is that the data are acquired and then processed locally by means of the AI model. And then the decisions are taken locally and then sent back immediately to the device, from the device to the patient. In the scenario number four, we have also not just inference, but also a personalization, a fine-tuning, a learning on the device. In this case, we have some data which are used not just for the inference, but also for the training of the model. So at the beginning, again, in the early stages, we can imagine the device which is able to acquire some data and then fine-tune the model to the specific person, and then use the model fine-tuned, so personalized on the data which have been acquired in the processing. So we have these four scenarios which can be here highlighted, summarized. We can divide it into inference on cloud and inference on device. If we start from the inference on cloud, we might have a predefined model or personalized model. If we consider the inference on cloud and predefined model, this is the most traditional solution that we can have. Quite straightforward, easy to implement. Here, the personal data must flow through the internet. We have a less effective, where less effective means general model, so not tailored to me. And the device is connected, so it cannot truly be considered an intelligent device. But then, as we already commented in scenario number 2, we might rely on some data in order to have a personalized model. This is a more advanced solution. We still have the need to move personal data from the device to the cloud through the internet. We might have a more effective model because the model is then personal to me. But again, still the processing is carried out on the cloud, so it is still a connected object. If we enter the truly 10ML perspective, where we have the inference on the device by relying on a predefined model, so a general model, here we can rely on the fact that the personal data remain on the device. It is typically a less effective model because it is a general model, but truly, if the processing is carried out on the device, it is truly an intelligent time device. Finally, if we are able to support the personalization, and we will see that we are suggesting a soft personalization of models directly on the device, we can support the 10ML for training, so on-device learning. In this case, the personal data remain on the device. We can have a personal model, so not general model. We have devices which are truly intelligent, but for sure we require a much powerful device because we can support not just the inference, but also the learning of the device. But this will pave the way, or will open the way for ethical concerns. Now we are switching the presenter, and I leave the stage to Viola.
Okay, thank you very much. Thank you, Manuel. Okay, I will share my screen now. And I hope that everybody can see my screen now.
Yeah, we do.
Okay, so let's focus now on the ethical concerns. As you can imagine, and already many of these concerns have been at least mentioned. And as you can imagine, there's already a vast literature on the ethical concern, in particular of health-related Internet of Things, and the general context that Manuel illustrated. But, and this is just an example, this is a narrative review on the ethical concerns and issues of health-related Internet of Things that is organized according to 3 dimensions, like the dimension of devices, in which, for example, some issues are related to personal privacy or social isolation when you have this kind of IoT context. The dimension of data, when, of course, in health context and scenarios, data are really sensitive. So you might have problems with data sharing, or how this sharing of data can impact on human autonomy. And also we can have the dimension of data of practices, like how the use of these tools can impact on the delivery of healthcare. And here again, an example is social isolation as a possibility. But what we did, it's a bit different from like just a very general review of the ethical issues, because we wanted to map the more general ethical problems in this field to the 4 different technological scenarios that Manuel just illustrated. And basically, this was the first step of our joint work. And basically, it was a step in which basically we took into consideration 2 dimensions. So the dimension of the contraposition between cloud services and on-device services, and the dimension in which we have sort of more traditional models, predefined models, and the dimension in which we have personalized models. So what is the result of this approach? The result is a kind of map. I hope you can see this map. Is quite articulated, but on in the columns, you can see the 4 different scenarios, and in the rows, you can see many of some of the problems we listed. And here, the point is that, of course, you can see that the concerns and the ethical issues are more or less the same in the different scenarios, but you can see that there are some differences at the level of the degrees of seriousness of these issues. And we represented with different lights, with different tones of gray. So you can see that in some cases, ethical concerns and issues are really serious. And so we use darker gray. In some cases are medium, and in other cases are less serious. And let me just focus on privacy now and see how can we better articulate this point. Because here the main message is it's important to take into account the technological details and the different scenarios to articulate in a better way also the ethical issues. So let's focus, for example, on privacy. And one of the problems here is constant monitoring and surveillance. And here you can see that, for example, as Manuel mentioned, there are cases in which, of course, you want to have more data. You need to collect more data when you want to develop personalized model. So here, for example, the problem of constant surveillance is very serious in the case of personalized models, and it's less serious, for example, in the case of predefined models. And the same hold so, for example, the same hold in the case of sharing personal data on the cloud with third parties. So here, once again, this is a very serious ethical concern in the case of personalized model, and it's less serious in the case of personalized of predefined models. Let's focus on another issue related to privacy. That is concerns on data control. And here again, we can see something that is, at least for us, quite interesting. Because let's focus, for example, on the case of the accessibility and transparency of cloud services. Here we can see that problems and ethical concerns are more serious in the case of cloud services rather than in the case of on-device services. And the same can be seen in the case of the security of personal data that, again, are very serious or let's say, potentially more dangerous in the case of cloud services rather than on devices. So what we want to emphasize with this kind of approach and emphasis on this case. And we can say that this is the first lesson that we learned in this project. We want to move beyond the quite simplistic view that basically, because you have more privacy on device, you have less problems from an ethical point of view. And so that tiny ML is better than other solutions because you don't meet the problems that you can have in the case of cloud services. Here, what we want to add, and this is the part on which we are going to focus right now, is that we have other problems. So it's not only a matter of a contraposition between cloud and devices, but we have problems related to personalization and personalized models. So let's focus now. So let's move beyond privacy and let's see that, of course, there are also technical ways of dealing with privacy problems. There are ways to mitigate privacy issues. Homomorphic encryption is one of them. Tiny machine learning is another. But here we want to focus that when we try to solve these problems, at the level of privacy, other problems emerge. And so we really always need to have a sort of trade-off between different choices. But let me better articulate this part now. So what about these new issues emerging beyond privacy, and in particular when we have technical means that can help us to mitigate privacy issues? Here is one possible example. And the example is that, of course, we can have good ways to make personalized models, encrypted models. But here now the problem is related to transparency. So this is the case in which if you don't have the secret keys as a user, you cannot inspect the model. So the model is protected in a sense from a privacy point of view, but the user, in a sense, has a sort of increasing burden because it's difficult to check the result of the model, of the learning phases of the model, and so the quality and reliability of the model itself. But let me mention again another example in this direction. And here again, this is an example that we can have, for example, when we adopt tiny machine learning to just try to overcome some issues at the level of privacy. And here we have the case in which these very highly personalized models that are also protected from a privacy point of view can run the risk to learn as normal some situations that are instead harmful for the health of the user. And the reason is that in this case, the model is trained directly on device. So there might be a sort of unpredictable evolution of the learning. And this is particularly serious in the case of health-related context, because if we are moving in this direction, like wearables and like digital health models, experts are increasingly less involved in these processes. So this is an important point. So let me focus now on this point and the idea that I hope we have shown that there are many values at stake, and that here the point is to try to find a way to deal with these different values and to interplay in a balanced way among epistemic and ethical values. Epistemic values are values related, for example, to I don't know, for example, the quality of the model. So epistemic means related to knowledge. So how to address these issues? Of course, there is no just a single way, but here we propose this idea, this approach. That is the idea of the soft personalization. Basically, this sentence summarizes in a nutshell the idea behind this approach. So here the point is that of course, personalization is powerful, and we would like, in particular, when we are dealing with health issues, we want to have personalized solutions. But at the same time, personalization might be dangerous in some situations. So we need to control, we want to control the learning and the evolution of personalized models. And we want to do this in accordance with ethical values and epistemic requirements, in particular, if we are moving in the biomedical context. This does not mean that privacy and security are not important anymore. It means that we want to have privacy and security remaining central, but we want to address also epistemic requirements, like we don't want to have models overestimating or not properly classifying problematic states and stuff like this. And we want to have also ethical values like traditional values in bioethics, like do not harm or make the good. So what's the point here? The point here is that we have to renounce to a very high level of personalization. And this is the main message. What does it mean in the case of the glucose monitoring that Manuel presented? It means that if we want to have a better control on the evolution of the model and the learning in the model, we can start from different models that, of course, start from personal data, but we also can also try to find ways to select and evaluate models by users and experts. And this is just in a picture trying to summarize these points. So perhaps I will move to the conclusion, but hopefully we will have time during questions and answers. Here, the idea is to have more conservative thresholds, more specific thresholds that try to cover some of the epistemic requirements like quality of data or the representativeness of the group. But this is a way also to guarantee more reliability in terms of the traditional bioethical principles like beneficence or non-maleficence. Of course, this is an approach in which you can see that there are many limitations, not only technical limitations, but also limitations at the ethical and epistemic level. Once again, the idea that if you start from many models, and then, of course, this evaluation of the models is also on the shoulders of the user, it means that users have a greater responsibility. And also a problem is related to the data that are at the beginning of this process. So the quality of the data plays a very important role. And it means that, of course, this requires a sort of Copernican revolution in the approach. It means that, of course, users need to be educated. It means that, of course, these are tools that are better to be used in collaboration between users and a sort of health ecosystem that can support them. And also it means that this is a kind of approach that needs to take into consideration that, for example, pathologies and lifestyles that are strongly related to some pathologies evolve over time. And so this approach should take into consideration this part. So what is the message here? The message is that it's impossible to solve all these issues only by technical means. So by technical means, I consider here algorithmic solution because it's always a matter of trade-offs. So that's why the importance of the context plays such a big role in this kind of discourse. And it's a matter of trade-offs because, of course, we want to have more efficient and more reliable and better in terms of quality models. But it's also true that we want also to maintain other values. And we see that when we want to have like solutions that are completely protected with respect to privacy, then other problems emerge. So there's no just one single solution, not even in philosophical terms, but of course not even in technological terms. So to conclude, we think that this kind of approach is promising in a sense. So we renounce to some of the personalization, but at the same time, we are better able to deal with other issues in terms of ethical concerns. But at the same time, we are very aware that there are many open issues and challenges in the context. It's true that in terms of privacy, there are already very innovative algorithmic solutions. And so it's important to take into account them in this context. But also it's important to try to move from privacy to other issues, and personalization is a way to try to mitigate some of the issues arising when we try to cover privacy as a problem. At the same time, it's very important to be aware that various trade-offs remain open. And this is very important. This kind of awareness is very important. So in a nutshell, to summarize this work and this research, it's exactly the attempt to try to fill in at least one of the gaps between the design and the development of tiny machine learning systems and the ethical concerns and values. So we are moving, we started from a sort of ethical analysis, we moved to the idea that we can try to solve some of these issues by algorithmic solutions, but we are moving back once again and also reconsidering that there's not just one single solution, but it's always a matter of trade-offs. So thank you for attention, and we are now ready for questions.
Thank you very much, Manuel and Viola. A round of applause here from my side on behalf of all the participants. So we have some questions. We have 5 minutes exactly for questions. So you can either read them in the chat or I can summarize them. Maybe we can start from this one from Nazir, which is, from Andrew, which is asking who is going to take action, right? Is it public, private institutions, or is it governments? I think it's a very kind of interesting question.
Yeah, it is super interesting. Here, as far as we designed this solution, we do believe that the actor in charge of designing that must be a trusted actor. So it could be for sure part of the public or private institution related to the medical perspective, because we need someone who is able to evaluate whether the possible soft model is good enough, because otherwise what we want exactly to avoid is the fact that the model evolves in an uncontrolled way. So for sure we need a medical evaluation, but in principle this could be also supported by a government solution. Yeah, so Marco, I do have some questions which are in the chat. I would like to answer, starting from the question from Alex about the federated learning. Alex, what we described today is not strictly related to federated learning. We could think about federated learning acting as a different perspective. Here, the idea is that we have a non-device training on strictly personal data, in the sense that we are retraining the model locally, just using data coming from one specific patient. In principle, we could integrate this perspective with a further level of federated learning, such that you can exchange data. This, opens the way for further level of concerns at different points or different perspectives. But in principle, we can integrate what we described from the federated learning perspective, which I don't know if you're aware about that, is related to the ability to exchange model and not data, which is good on one hand because it allows to have better models in general, because we are then aggregating different models, but this does not prevent possible leakage of data. So that's not a secure enough solution. As regards the next question from Andrew related to the security, that's a super cool question, which is associated to the need to protect our devices. how secure that's the answer is the device is secure if no one can gain access to that. So in principle, an attack can be carried out if the attacker can inject some code, or if the attacker can access physically the device. In principle, if we have just firmware with protected access, then it is a safer solution than allowing external user accessing the device. Let me just mention what happened in 2016 with the Mirai botnet that introduced, well, that's affected the Twitter, LinkedIn, Facebook the same day, introduced by means of a denial of service attack. And this attack has been carried out by taking the control at first of IoT devices. In those cases, CCTV cameras are more powerful devices than Arduino. Then there was the question from Alex, which was about the hardware. Is the hardware ready for the retraining? The answer is, well, today it is very difficult. This means that we cannot perform regular training algorithms like backpropagation for two main reasons. The first reason is the complexity, and the second reason is the need of a large data set on that. But this does not mean that in the future we will not be able to do that. This means that we are designing different learning algorithms which are able to be lighter than backpropagation, and then we are designing learning algorithms that are able to exploit less data in a sort of online learning.
Okay, I think we need to.
Viola, I took the floor. Maybe there are.
No, sorry. I have just want to answer to the next question: how artificial intelligence can be used unethically in healthcare, how to prevent AI errors, and who is responsible for AI mistakes. So this too many questions, and of course can be used unethically in many ways. And this depends also what you mean by unethical. It means like it's not privacy compliant. That's an issue, but can also be a way of using in healthcare, like when you want to push people to have some behaviors, and so you can just nudge them to have some behavior. Also, if these behaviors are for health purposes, like, for example, the kind of food you eat or stuff like this. So these are very delicate questions. And so, yes, there are many ways in which artificial intelligence can be used unethically, also less obvious than those that are discussed today in the public discourse. How to prevent errors? I think that there's not just one single way, but I think it's very important to educate people and to have also future generations of computer professionals, computer engineers, people working in these technical fields to be aware of these issues. And it's not enough to have to design for the good. There are also unintended consequences, problems, and it's very important to take into account them already from the beginning. And who is responsible for AI's mistake? Of course, not AIs themselves. They are not moral agents in a sense. So it's a mix of responsibility in a sense. And this is exactly what sits under discussion today in Europe with the development of the Artificial Intelligence Act that will be possibly the first regulation of artificial intelligence. But this is a huge question. So I don't know if we have time. I see other messages.
So thank you so much, Viola and Manuel. That was super interesting. And as you see, there's lots of questions. I don't know if you're aware, we have a Discord channel where we talk about TinyML, and we have a special discussion about this workshop. So I will send you the link if you're not part of the Discord, so that people can ask you more questions and send you more comments on Discord. So again, thank you so much, and
thank you for the invitation. It's very valuable for us to present this kind of strange work in which we try to mix different perspectives. So thank you so much, and thank you for the questions.
Thank you.
Thank you. Thank you.